Okay, so here we're going to subtract or do addition subtraction of rational expressions, but this time with different denominators. So this is going to require us to use that LCM, or otherwise known as an LCD, because we're going to be looking at just denominators. So we're going to find this LCM or LCD. And for each rational expression, we're going to find an equivalent expression with the same LCD. To do so, we're going to multiply by 1 by using expression of 1 made up of factors of the LCD, which means instead of, like if we find that we need to multiply by a 2x to get the same LCD, we multiply the top and the bottom by it. Then we're going to add subtract the numerators, because ideally we should have the same LCD, so we have the same denominator. And then we're going to write the result over that LCD that we found, and then we're going to simplify. So here we have 5x over x squared plus 5x plus 6. And this is all added to the other rational expression of 3x squared plus 4x minus 21. So I need to find an LCM of the denominators. Or what we're looking for is called our LCD, so it's our least common denominator. So if I look at these, my denominators, I have x squared plus 5x plus 6, which is factors into x plus 6, x plus 2. I keep doing this one, same one, x plus 2, x plus 3. If I look at my x squared plus minus 4x minus 21, that one factors into x minus 7 and x plus 3. So my LCD, or LCM, means I need to take down every factor that appears at least once, which means the x plus 2, that is a factor that appears once, x plus 3 I have, and the x minus 7. So remember, this one appears twice, but I only need to record it one time. And everything has a power of 1 to it. So my LCM is going to be x plus 2, x plus 3, x minus 7. And we know if I divided by each one of these, if I divided by the x plus 2, x minus 3, then I'm just left with x minus 7. If I divide by the x minus 7, x plus 3, then all I'll be left with is the x plus 2. So both of my denominators are divided into this number. But what we see here, I'm going to rewrite. Second, trying to get the right number color here. So we're going to rewrite this as a 5x. And now we know that denominator breaks up into x plus 2 and x plus 3. And what I'm trying to do here is make sure they have the same denominator, and that same denominator is going to be this CD. So this is going to be my new denominator. So to get this new denominator, all I need to do is I already have the x plus 2 and the x plus 3, is I need this x minus 7. So I'm going to multiply x minus 7 to the bottom, but I also have to multiply that to the top. So this is basically multiplying by 1. So I'm going to keep an equivalent rational expression. So my 3x squared minus 4x minus 12, we know is just 3 over x minus 7, x plus 3. Then we go to back to my new denominator. I already have x minus 7, x plus 3. I don't have plus 2. So I make sure I multiply the top and the bottom by x plus 2. So now I'm just multiplying by 1. So what I did is basically take my fractions or my rational expressions, and I'm going to rewrite them as equivalent ones that have the same denominator. So now I'm going to end up with 5x times x minus 7. Actually, maybe write that below it. I'm not going to have enough room here. 5x, x minus 7. And now that's going to be divided by x plus 2, x plus 3, and x minus 7. So I got my LCD as my new denominator. And then I'm going to have 3 times x plus 2 over x plus 2, x plus 3 over x minus 7. So I'm just taking this denominator and rewrite it so it looks the same. Okay, so what I have here is I'm just going to have 5x, x minus 7, plus, because now I can add those denominators, or sorry, those numerators, because I have the same denominator. So 5x plus times x minus 7 plus 3 times x plus 2, and then all over the denominator of x plus 2, x plus 3, and x minus 7. So we get 5x squared minus 35x plus 3x plus 6 over x plus 2, x plus 3, x minus 7. So I'm actually going to go through and I'm going to do this. I need to finish this out. So we're going to take out this little part about the LCM. And I'm going to continue up here. So we have 5x squared minus 35x plus 3x plus 6, x plus 2, x plus 3, x minus 7. Okay, so simplify that top, we're going to end up with 5x squared minus 32x plus 6. Okay. And then the top, I do not believe I can factor that. Get to that 30. Yeah, so I can't think of two numbers that multiply, give me 30 and give me 32. Yeah, so I believe that we're good there. That's where we're going to stop. So sometimes you might see the bottom would be expanded out. Just a second. Stop for a second there so I can just do this little work for you. So if we took that bottom, we expanded it. So we'd end up with 5x squared minus 32x plus 6. And that would be over if I took x plus 3, x plus 2, and x minus 7, and I expanded that, that would be x cubed minus 2, x squared minus 9x minus 42. All right, so one more example. So this one is another one that's a little bit of a trick here. So notice I have 3x squared minus 1 and I have 1 minus 3x squared. So in this case, it's like what we had before. We have the same numbers, just we basically have what's considered an additive inverse. So my two terms are flipped. So if I wanted to, I can take it and essentially I can factor out a -1 out of the second one, and that will change it. So this is not a -3y squared, it becomes a positive 3y squared, and it's not a positive 1 now, now it's a -1. So this -1, so we got a -1, and then this -1 here. So this is just 2y plus 5 over 3y squared minus 1 plus 7y plus 2 over 3y squared minus 1. So sometimes just be careful that all you have to do is actually just pull out a number or -1, and you end up with the same denominator. So we'd end up with 9y 5, 6, 7 plus 7. So our last bit for this, so just take a moment and just try to find the same added LCD if you can, or see if there's another way to rewrite this. So we end up with two rational expressions of the same denominator, so then we can add them together. All right, so for A, if we took those bottoms, those denominators, we have 8x over x minus 3. X minus 3 cannot be factored any further. And then we have 5 over x squared minus 9. That can be factored further into 5 over x minus 3, x plus 3. So if we focus on just those denominators, and we want to find that LCD, we would have to have an x minus 3, because both of them have that. And then we'd have this x plus 3, because that's at least a factor of another one. So every factor that appears, and they all have a power of 1. So in this case, the only thing we'd have to do is just take my 8x over x minus 3 and just multiply the top and the bottom by x plus 3. So we'll end up with the same denominator. So sometimes you don't have to multiply both numbers. Now, if I do that, I'm going to end up with 8x squared plus 24x over x minus 3 times x plus 3. And that is going to be added to 5x minus 3, x plus 3. So we're going to end up with 8x squared plus 24x plus 5 over x minus 3, x plus 3. All right, just quick here. Let me see. And then that will be 40. So I believe we can actually factor the top. It's just, do we need to? Well, let's quickly just check that out. See what happens. So we always have to just check to see if we can simplify further. So I'm going to just look at 8x squared plus 24x plus 5. So an AC is going to be 40. I need factors of 40. And I need those factors to sum to 24. So if we have 20 and 4, that is going to give me 40. If I do 20 plus 4, that gives me 24. So we can turn this into 8x squared plus 20x plus 4x plus 5. If I factor out a 4x, then I'm going to have second here. Let's think if this is actually going to work. We could factor out maybe this doesn't actually factor. Oh, silly me. 20 times 4 is 80, not 40. So there is not two numbers that are going to give me, that are factors of 40 that are going to give me 24. So this is actually simplified. So this is my final answer. We just could go a little bit further and just say that's going to be 8x squared plus 24x plus 5 over x squared minus 9. All right, so for B, let's factor those. Get a better contrasting color. So if we factor the denominators, we're going to have x over x plus 3, x plus 1. And then the other one, that's going to be 3 over x minus 5, x plus 1. So what we see here is that they both have a plus 1. This has an x plus 3, and this has an x minus 5. So basically I'm going to take those terms, instead of like looking for my LCM, I can just say, hey, if I take my x over x plus 3 times x plus 1, the one thing it's missing on the bottom is that x minus 5 the other side has. So I multiply the top and the bottom. So I'm really just taking the missing term, or not missing term, the missing factor. And then 3, x minus 5 times x plus 1. This one over here has an x plus 3 that it doesn't have, so I multiply both sides by the x plus 3. Or you could have said, looking at the LCD of the bottom would actually have been x plus 3, because we have an x plus 3, and then we'd have an x plus 1, because we had an x plus 1 in one of my denominators, and then we'd have an x plus 5, because that's in one of my denominators. So you can also go with the LCM. Like I said, I was just kind of skipping that, going, well, I know I have an x plus 1 in both denominators. I just need to use the other factor on both sides. So this is going to give me x squared minus 5x over x plus 3 times x plus 1 times x minus 5. And then we're subtracting. Now what we have over here is going to be 3x plus 9 over x plus 3, x plus 1, x minus 5. What we're going to end up with down here is this little blue part, oops. So we can see what I'm writing here at the very bottom. So what you're going to end up with, if we add the tops, is you're going to end up with an x squared minus 5x. And then remember, we're subtracting, so we're subtracting 3x, and then we're subtracting 9. And they have that same denominator, so we're going to have that denominator of x plus 3 times x plus 1 plus times x minus 5. So on the top we have x squared minus 5, 6, 7, 8, 8x minus 9 over x plus 3, x minus 1, x minus 5. And the top can actually factor 2 into x minus 9 and x plus 1. So this is why we've just been leaving things the way they are to the very end, because sometimes we can figure out that even actually after we add and subtract, we can still simplify that final answer. So we can take out that x minus 1, and I'm really just left with is just x minus 9 over x plus 3 times x minus 5. Or we can say x minus 9 over x squared minus 2x minus 15.